Good morning to everyone. Today we will learn the next cubic unit cell. Already we have learned the simple cubic unit cell. Now we will learn the next cubic unit cell. We know that there are three types of unit cell, that is simple cubic unit cell, body centered cubic unit cell, then face centered cubic unit cell. In the last class we saw about the packing fraction or packing efficiency in simple cubic unit cell. Now we will learn the packing efficiency in body centered cubic unit cell and face centered cubic unit cell. Okay, so the same concept we are going to apply in the body centered cubic unit cell as well as face centered cubic unit cell. So it seems very difficult, but it is very easy. You listen to the class carefully. Okay, so packing fraction or efficiency, we know it is equal to total volume occupied by spheres in unit cell divided by volume of unit cell into 100. Okay, that is taken as first equation, and you consider one unit cell. We know that in a crystal more number of unit cell will be present. It is a repetitive unit. Okay, so you take only one unit cell. In that unit cell you take one part, that is this triangle ABC. See, you can see in triangle you take this triangle alone, ABC. So in triangle ABC you see AC squared is equal to AB squared plus BC squared. Okay, so when you square this one, you get AC is equal to root of AB squared plus BC squared. Root of AB squared plus BC squared, then AC will be equal to, then you substitute for AB will be equal to what? AB will be equal to A. Okay, so AB will be equal to A, then for AB you substitute A, then for AB squared it will become A squared plus A squared. So root of A squared plus A squared, it will be equal to root 2 A squared. Okay, root 2 A squared. Then when you cancel this root, you get this square and root will be cancelled, then you get AC is equal to root 2A. Okay, root 2A. So AC will be equal to what? Root 2A. Okay, so then you consider the next triangle. So in the triangle consider பண்ணியாச்சு. அடுத்த triangle எடுங்க. What is this triangle? ACG. Okay, so we are considering the next triangle ACG. Okay, so in ACG, similar to that one, AG squared is equal to AC squared plus CG squared. AG squared is equal to AC squared plus CG squared. So here AG will be equal to, when you take the square root, will get root of root AC will be equal to what? Root 2A. AC will be equal to root 2A. So you substitute for AC. So it will be root 2A squared plus A squared. CG will be equal to how much? CG will be equal to A. Okay, CG will be equal to A. So it will become what? A squared. So root 2A squared plus A squared. So it will be equal to root 2A squared. So root 2 cancel, then it will become root 2A squared plus A squared. Root 2A squared plus A squared. Then it will become root 3A squared. Root 3A squared. So here AG will be equal to what? Root 3A squared. Now AG is equal to, when you take the square root, you will get this square and root will be cancelled. Then you will get AG is equal to root 3A. That is root 3A is equal to what? So you listen. AG will be equal to what? AG will be equal to root 3A. Then this root 3A will be equal to what? This one, 2R. So this root 3A will be equal to what? 2R. R is nothing but the radius. Okay, 2R. Then when you substitute this one for 2R, when you substitute, you will get root 3A is equal to 4R. Then R is equal to root 3. This 4 will come to this side. Okay, root 3 by 4A. So R will be equal to what? When you rearrange this equation, you will get R will be equal to 4 will go to that side, then R is equal to root 3 by 4A. So R value is what? R is equal to root 3 by 4A. R is nothing but the radius of the sphere. R is nothing but what? Radius of the sphere. We know that volume of the sphere is equal to 4 by 3 pi r cube. 4 by 3 pi r cube. Okay, 4 by 3 pi, substitute for R. Okay, R will be equal to root 3 by 4 A power cube divided by root 3 by 16. Root 3 by 16, it will be equal to 4 into 4, 16. So root 3 by 16 pi A cube. That is the second equation. Then number of spheres that belong to BCC will be 2. SC number of spheres belong to SC will be 1. Here number of spheres that belong to BCC on the another, it will be 2. So volume of spheres Okay, total number of spheres or volume of spheres in unit cell. Okay, it will be equal to 2 into, you substitute for what? 2 into root 3 pi a cube divided by 16. So it will be equal to, so here 2 divided by 16 it will be 8. So root 3 pi a cube by 8, that is the third equation. So now you substitute 3 in this equation. Substitute 3 in this equation. So we have calculated total volume occupied by spheres in unit cell, that is this one. So other divided by, what is the volume of unit cell? Already in SC we learned that volume of cubic unit cell is equal to a cube. So root 3 pi a cube by 8 by a cube into 100, it will be equal to root 3 pi by 8. Root 3 pi by 8 into 100. Root 3 pi by 8 into what? 100. So here root 3 pi into 100 by 8, it will be equal to 12.5. So root 3 pi into 12.5, root 3 value is what? 1.732 into pi value will be 3.14 into 12.5 will get 68%. So the packing efficiency of body centered cubic lattice is what? 68%. So see, so in 100%, 68% is occupied by the atoms in body centered cubic lattice. Then packing fraction in FCC, that is face centered cubic lattice. Here the formation of first layer is there, that is the atoms are arranged one above the other, and in between it will have some voids. Okay, the larger anions will occupy the space, and as well as the cation will occupy the voids or holes, or in between those atoms these cations will be present. That is the formation of first layer. Formation of second layer will be in between the voids or holes, the atoms will be arranged. That is the formation of second layer. Then formation of third layer, you will have hexagonal close packing and cubic close packing. You will have AA type as well as AB type in this one. Okay, here the neighboring unit cell or the coordination number will be 8. The coordination number in FCC, it will be what? 8. So here AC will be equal to 4 and 4R is equal to A root 2 and R is equal to A root 2 divided by 4. So R inga irukna 4 inga kondu vanditingina, it will be A root 2 divided by 4. Now anga paatha mariye here also you consider triangle ABC. So in FCC unit cell triangle ABC consider pannanga. In the triangle ABC consider pannina, in triangle ABC AC squared is equal to AB squared plus BC squared. So it will be equal to root AB squared plus BC squared. Then AC is equal to, substitute for AB will be equal to what? A. Then BC will be equal to what? A. So AC is equal to root of A squared plus A squared. It will be equal to root 2A squared. Then you cancel this square and root, we get root 2A. Then volume of sphere. So we have find out AC is equal to root 2A. Then we know that volume of sphere is equal to 4 by 3 pi, and R you substitute this what? R you substitute this root 2A divided by 4. Here it is there. Okay, A root 2 divided by 4. So root 2A by 4 cube. Then 4 by 3 pi, it will become 2 root 2 A cube. So when you take the cubic root, we will get 2 root 2 A cube divided by 4 cube and 64. Then it will be equal to, when you divide by 4, you will get what? 24. Okay. So here 24 into 4 you will get what? 64. So it will be 24. Okay. So you divide by 4 divided by 64, here 24 will come. So it will be equal to root 2 pi A cube divided by 24. So here the total number of spheres that belong to FCC is what? 4. So inga total number of spheres in SC vandu 1, BCC vandu 2 and FCC vandu enadhu 4. Okay. So therefore volume of all spheres in FCC, it will be equal to 4 into root 2 pi A cube divided by 24. So it will be equal to root 2, then 4 divided by 24, it will be 6. Here it will be 6, 1 by 6. Okay. So root 2 pi A cube divided by 6. So here you substitute this one in the first equation. Okay, that is the packing fraction or packing efficiency equation. So total number of spheres in the unit cell, it will be equal to root 2 pi A cube divided by 6 divided by volume of the cube is how much? A cube into 100. Now when you arrange or when you divide this equation, you get root 2 pi, that is A cube will be cancelled, then you get root 2 pi by 6 into 100. A cube cancel ஆயிட்டுனா உங்களுக்கு என்ன கிடைக்கும் root 2 pi by 6 into 100. Root 2 value will be 1.414. Root 3 க்கு 1.732. Root 2 க்கு 1.414 into pi value will be equal to 3.14 into 100 divided by 6, it will be equal to how much? 74%. So compared to this SC, BCC, FCC has more packing efficiency or packing fraction. So what is the tightly packed or closely packed arrangement? FCC. So FCC is the tightly packed or closely packed arrangement, or in FCC there is sufficient packing or efficient packing in FCC. So compared to SC, BC and FCC, FCC has efficient packing of atoms in the crystal, okay, and this SC has the less insufficient packing of atoms in the crystal. We know that in FCC it is 52 and here in BCC it is 68%. It can be asked in one word, okay, 68%, and in the FCC the packing fraction is 74%. Now the total number of spheres that belong to FCC will be 4, and the total number of spheres that belong to BCC will be 2, and the total number of spheres that belong to SC will be how much? 1. So this can be asked in one word, okay. Now radius ratio. So in radius ratio, the stoichiometry and size of the ion determines the structure of the crystal. Stoichiometry என்னது number of reactant A எவ்வளோ இருக்குது, B எவ்வளோ இருக்குது, ஈக்குவலாக இருக்கா அப்படின்னு சொல்கிறது தான் என்னது stoichiometry. அப்புறம் size of the ion வந்து எதை டிசைட் பண்ணுது? structure of the crystal. And the larger anions, they will occupy the crystal. பெருசாக இருக்கிற ஆனையான்ல முதல்ல உட்காந்துட்டு then the cation, it will occupy the voids or spaces or holes. அந்த ஸ்பேசஸில் போய் யார் உட்காந்துருப்பா? cations. Cation will be smaller in size, anions will be larger in size, because anion gain electron, cation lose electron. அதனால் கேட்டையானுக்கு சைஸ் கம்மியாக இருக்கும், ஆனையானுக்கு சைஸ் அதிகமாக இருக்கும். அப்போ என்ன ஆகும்? அந்த மோர் ஸ்பேஸை யார் ஆக்குப்பை பண்ணிக்கிடுவா? ஆனையான். அந்த கேப்புக்குள்ளே போய் யார் உட்காந்துருப்பா? திஸ் கேட்டையான்ஸ், ஓகே. ஸோ இதில் ஸ்டாக்கியோமெட்ரியும் சைஸும் தான் என்னது நம்மளுடைய ஸ்ட்ரக்சர் ஆஃப் த அயானை வந்து டிட்டர்மைன் பண்ணுது, ஓகே. ஸோ ஹியர் த ரேடியஸ் ரேஷியோ இஸ் நத்திங் பட் த radius of cation divided by radius of anion, that is RC plus divided by RA minus, okay. So that determines the what structure of the ion. So this radius ratio is also very very important, and one tabular column is given in your book, that is a coordination number is given, radius ratio is given, and what is the shape? For example, when the coordination number is 3, then it is trigonal bipyramidal. And what is the example? B2O3. So for 3, 4, 6 and 8 coordination number, one table is given, and that table you thoroughly learn. Most of the one word will be asked from that tabular column, okay. So we have completed this lesson, solid state, and in that we have learnt about the classification of solid. I will give a summary of this lesson because we have completed 2 lessons, that is first lesson as well as the solid state, that is very important lesson in physical chemistry, okay. So we have completed the classification of solid, introduction about the solids, its properties, classification of solids, crystalline solid, amorphous solid, ionic solid, their arrangement, and then we saw about unit cell, okay, simple cubic, body centered cubic unit cell, face centered cubic unit cell, different types of cells, okay, unit cell we saw. Then we saw about the different arrangement and imperfections in solid, defects, point defect, Schottky defect, Frenkel defect, metal efficiency defect, and impurity defect. So everything we have learned, and we have also learned the packing in crystals, okay. Today we have learned the packing in crystals, that is the linear arrangement of crystals. Then what? Then the 2-dimensional packing, we learnt about 2 types, AA type, AB type, and we have learnt the packing fraction or packing efficiency in simple cubic unit cell, that will be 52%, and packing efficiency in body centered cubic unit cell, that will be 68%, and packing fraction in face centered cubic unit cell, it will be equal to 74%. So today's assignment is you learn and write the packing fraction and packing efficiency of body centered cubic unit cell and face centered cubic unit cell. So today's assignment is learn and write, okay, learn and write the packing efficiency, learn and write the 2 questions, packing efficiency of body centered cubic unit cell, Okay, so simple cubic unit cell, it is represented as SC. Body centered cubic unit cell, it is represented as BCC. Then face centered cubic unit cell, it is represented as FCC. Okay, so packing efficiency in BCC, it is also a detailed question, and packing efficiency in FCC. Okay, packing efficiency in FCC. So these two questions you learn and write. Okay, packing efficiency in FCC. Okay, so you refer to the book. Okay, your first reference must be book, and the second reference will be your guide. Okay, don't look into your guide first itself. You find out the answers for the questions that is given back of the book, inside the book. Okay, don't refer to the guide. Your first reference must be the book, and because the key will be prepared from the book only, our textbook only. Then don't refer to the guide in the first time itself. Okay, if you can't able to get any answer from the book, then you can refer to guide. Don't look at the guide first itself. Your first reference must be the book. Okay, second reference or third reference will be your guide. Okay, so learn and write this packing efficiency in BCC, then packing efficiency in FCC. You do the assignment on the day itself, assigned day itself. Okay, don't postpone. I'm always there to check your assignment. Okay, if you have any doubt, you can make a call and ask me. Okay, thank you for listening to me. Thank you.